this is lesson 3.5. Use ColorAdjust, ColorInput, and ImageInput. Let's begin with the ColorAdjust effect. This effect lets you adjust pixels so that you can control the brightness, contrast, hue, and saturation for a given input. This input can be an image, node, or another effect. Here are the properties. Hue is the amount to adjust the hue of each pixel. Saturation is the amount to adjust the saturation of each pixel. Brightness is the amount to adjust the brightness of each pixel. And contrast is the amount to adjust the contrast of each pixel. Now the range of all four of these properties is -1 to 1, and a value of 0 leaves the property unchanged. And last, the input property, which is used for chaining effects. Let's show you a JavaFX program now that uses the ColorAdjust effect. This is the ColorAdjust program that shows you how to apply the ColorAdjust effect to an image. Let's compile and run this program and examine its output. What you see is a colored image displayed. Note that this image looks different from the original one shown here. Let's show you the JavaFX code for this program now. First, the program creates a ColorAdjust object with a default constructor. The ColorAdjust setters set the hue property to -0.05, the contrast property to 0.1, the brightness property to 0.1, and the saturation property to 0.2. These settings make the tree look pinker, the sky bluer, and the ground more brown. Next, the program creates an image object from the trees.jpg file shown in the resource directory of this project. To view the image, the program builds an image view object using an image view constructor with the image object as its argument. The call to set fit width sets the width of the image to 425, the same width as the scene. And set preserve ratio true makes the image fit into the boundaries of the scene and preserves the aspect ratio of the image. The call to set effect here applies the ColorAdjust effect to the image view object. And finally, here's where we add the image view object to the root scene graph. Let's experiment with this program now so you can learn more about the ColorAdjust effect. First, I'll change the hue adjustment to a much larger positive value, 0.5, and increase the brightness to 0.5. When I recompile and run this program, the image looks really different now. And if I disable the ColorAdjust effect here and recompile and run, you see the colors of the original image. I'll let you experiment with the other ColorAdjust settings to see how it affects this image. The next effect is ColorInput. This effect lets you flood a source node with a solid color rectangular region. The coordinates, width, and height of the rectangular region are specified in a coordinate system relative to the source node. Here are the properties. X and Y are the coordinates of the flooded region relative to the content node. Defaults are 0. Width and height are the width and height of the flooded region relative to the content node. Defaults are 0. And paint is the color to flood the region and has a default color of red. Okay, let's show you a JavaFX program now that uses the ColorInput effect. This is the ColorInput program, which shows you how to use the ColorInput effect. Let's compile and run this program and examine its output. What you see is a circle with a linear gradient and text string inside a colored rectangle, all on a light yellow background. A blending effect also appears inside the circle. Let's show you the JavaFX code for this program now. First, the program creates a ColorInput object. The constructor builds a ColorInput rectangular region at 70/70 with width and height 160 and fill color steel blue. Next, the program creates a blend effect with a constructor that sets the blend mode to color.burn. And here is where we set the top input of the blend effect to the ColorInput effect. Note that the color input object doesn't do anything interesting by itself. It just serves as a color input to another effect, in this case blend. Next, the program creates a linear gradient. The coordinates make the gradient diagonal, and setting proportional to true makes it stretch. The gradient is also reflective, with stops from light steel blue to pale green. When the program builds the circle object at 150, 150 with radius 75, the linear gradient is applied here. A text constructor builds the text object at 100, 150 with the text string. The setters configure the font and set the fill color of the text to violet, and this statement adds the circle and text to the root scene graph. And here's where we apply the blend effect to the root. Let's experiment with this program now so that you can learn more about what the color input effect is doing. First, I'll remove the color input here by not invoking the set top input method. When I recompile and run this program, you see that no rectangular region and blending is only applied to the circle, gradient, and text. Note that the blending has been reduced slightly without the flooding of the rectangular region. And finally, let's show you what happens if I remove the blend effect completely by not invoking the set effect here. When I recompile and run this program, the scene is now much lighter because no blending was used. The last effect in this lesson is image input. This effect lets you attach a source image to another effect. The source image is unmodified when it's used as input to the other effect. Here are the properties. X and Y are the coordinates of the image relative to the content node. Defaults are 0. And source is the source of the image. Let's show you a JavaFX program now that uses the image input effect. This is the ImageInput program, which shows you how to use the image input effect. Let's compile and run this program and examine its output. What you see is a slightly blurred image with a white border, sort of like an out-of-focus photograph. Note that this image looks different from the original one shown here. Let's show you the JavaFX code for this program now. First, the program creates an image object with this image constructor. Here we specify the location of the image along with the requested width 425 and requested height 340. The constructor also sets the preserve ratio and smooth Boolean properties here. The true values preserve the aspect ratio of the image and provide smoother filtering. Next, the program builds an image input object using the image object. These XY coordinates keep the image input centered. Here is where we create the Gaussian blur object and set the input property of the Gaussian blur to the image input object. So what we have essentially done here is use image input to attach an image to a Gaussian blur effect. All that's left is to apply the Gaussian blur effect to the root. Note that we can't add anything to the root scene graph in this program because the Gaussian blur effect is not a node.